Also, again, as a reminder, I do have office hours today. I will send out the link after class, if you need to see me. You can also email me if you can't make office hours. I'll get back to you as quick as I can. So here we go. All right. Okay, here's another example. This is actually what I said earlier. If you go out to eat or something, right, and you want to leave a tip for the waiter or the waitress, whoever served you, a tip is a percentage of the bill. So we're dealing with percents again. Just trying to show you that math is everywhere. It's all around us. So it's not just the way of thinking that's important. It's all around us. So, mathematics. It's also fun. So the bill for dinner, let's say, turns out to be this amount. We want to know, okay, and let's say for, I don't know if this is under or over tipping or whatever, but let's say for some reason you decide to leave 7% tip. Let's say you decide to leave that. The question now is, well, how much is the tip you leave? Well, it's 7%, 7% of the bill. So to get the tip, we have a percentage. It's kind of like with tax, but instead we have tip. It's a certain percentage of the purchase. And that's what I'm doing here. 7%, I wrote it as a decimal, right? Tip is the part, whole is the bill, the purchase. So to get tip, we just multiply. Like so. Okay? So this is what we end up getting. So tip is this product, okay? And so from here, we get our tip to be this product, which is $8.09, as you can see. Okay. All right, so that's what happens here. Okay. So hopefully that wasn't too bad, but now let's kick it up a notch. That is, let's consider this now. Now we're going to go to dinner. Let's say now we're going to get, the bill comes and everything, but now we're going to assume that including the tip, this is how much you pay. So now that's not just the bill, that's the tip that includes the tip as well. But now the question is, okay, well, how much was the bill without the tip? Well, how would we get that? Okay, well, I know it's a little weird, this one, but let's see if we can figure this out. In fact, let's see if we can figure out what this is. Okay, so again, we want to know, like I just said, how much the bill was before the tip. Again, as stated here, this includes the tip. Well, let's get some notation set up. Let's say B was the bill, but B, we don't know what that is. So B is taking the role of our X here. Okay? B is taking the role of our X. Then what we have is B plus the tip is equal to this. That's what the problem is telling us. That B plus the tip, of course, that's kind of obvious what that is. Well, you know what I mean. We get this. But now we can do more though, right? Because we know the tip, right? It is in fact 7% of B. Okay, so algebraically, what is this? Well, since the tip again is 7% of B, that tells us, let me just draw parentheses in. This tells us that the tip is B times 7%, which is again B times 0.07. So if we were to put that into this equation, what we really have then is this, B plus 0.07 times B. That's actually what we have here. So again, the tip is 7% of B, right? And 7% of a number, that's the number times 0.07. So we're plugging that into the equation. But now what can we do? Well, we can combine these. Basically, we could factor out b. Factoring out is the same as basically distribution in reverse, meaning if you take b out, you get this. In other words, what we're basically doing here is we're using distribution in reverse. You know, if you were to distribute this, right, you would actually get over here. Factoring is the opposite. But 1 plus 0.07, that's 1.07. So we get this here, as you can see. But now we're good because now we have the unknown b times a number is another number. So we just divide and we get b. Okay. So that's how we get the bill before the tip. Intuitively, it kind of makes sense also, right? I mean, if the tip is 7%, this is basically telling you that the bill plus 7% of the bill is equal to this. In other words, 107% of the bill is equal to this. That's really what this is saying over here. 107% of the bill, which is the bill times 1.07, is equal to this. You know, the calculation tells us more than numbers, so to say. So thought that was really cool. All right. Okay, so that's one problem. Here's one I want everyone to try. Let me just pause the recording because I want